All right, so 1.1, we're going to be looking at rates and ratios. And back in baby school, I think you guys learned about unit rate. Did you?
Yeah.
Yeah, you remember doing that? So it was like if you had like 10 cookies and 5 kids, you want to know how many cookies per one kid? Does that sound right? So you want to one unit on the bottom. And what did you do? Did you? Divide, right? You divide, okay? We're going to do combination of multiplying and dividing, right? So we're going to be looking at, unit rate effectively here. Unit rates. And also, I'm going to start to introduce what's called unit conversion. And it's a method that it's kind of neat. It works. A lot of times, kids are trying to convert units, feet and miles per hour and feet per minute and all that. And you get stuck. Do I multiply? Do I divide, right? Well, the way I show you how to set this up with these simple examples will really help you with that, okay? So we are going to look at unit conversion as well. Or unit analysis, I think is the new woke term for it. I don't know what's going on here. Okay. Okay, they say a lot of stuff at the top here. But we're going to talk about some ratios. A ratio can be just like a rate, right? Like miles per hour, yeah? Okay, or did you guys ever, you remember doing lines y equals mx plus b? What was the m? The slope, right? And did they tell you slope is like a rate of change? Okay, yeah. So slope could be a rate, no word problem, right? Let's just kick out some examples here. And as I write stuff, you write it, okay? And the way I write it is how I want you guys to write it as well, right? Because algebra is a language, wouldn't you agree? It's like an efficient language to communicate, yes? Right? Okay. And English is used to communicate. Maybe some of you are taking Spanish, right? And there's certain rules to the language, right? So that when you communicate effectively, it all makes sense to somebody else, to a listener, okay? It's the same with algebra. Sometimes I think that kids that take algebra should also get a foreign language credit, because it's a language, if you ask me. And in that sense, I treat it like grammar, okay? I'm really picky about grammar. Yes? Yeah, okay. All right, remember this will be on Teams a little later, okay? Anyway, that being said, let's go on to this first example. So let's answer the following various questions using multiplication and or division. So yeah, we're going to show our calculations, okay? Keep track of units. So part A, we've got 12 eggs per carton, okay? 12 eggs for how many cartons? Well, no, just look what I underlined. One carton, so one carton has 12 eggs. That sounds like a unit rate, doesn't it? I want to know how many eggs do we have in 5 cartons. I want to write this out with the units for now, okay? And I know like right now intuitively you know what to do probably, right? Which is multiply and get the number of eggs. But there's little simple examples when I want to kind of put in this unit conversion to help you. So if I write this as a rate, 12 eggs every carton. 12 eggs every 1 carton. And you know that horizontal line means to divide, right? It's a division line, yes? Okay? It's also a grouping symbol. We'll get back to that later, okay? So now, let's multiply by 5 cartons. And I'm going to do this. You probably learned somewhere that you can write any number over 1 and it's the same, right? I'm doing this for a reason here. Because when I have a fraction, and I have the same thing that's in the top of the fraction as the bottom of the fraction, you guys remember that they cancel out, right? They divide out, okay? And that also works with units, not just numbers, okay? So, for example, if I had 5 and a 5 down here, the 5s would cancel, yes, and they'd go away. It'd be 1, but effectively they'd go away, right? The word carton is top and bottom, right? So wouldn't cartons cancel? Right? Just the word itself cancels. And what unit am I now left with? Eggs. Yeah, that's what they wanted. How many eggs? Well, I set it up so everything canceled but eggs, the thing they want, right? And so now I know I do what? 12 times 5, which leaves me with what? 60 eggs, okay? Can I get a sense a little bit there? I know this is a simple one, you probably had just multiply it, right, by 5. Okay, but when they get more complicated, later on you're going to be wanting to convert like feet per minute to miles per hour. And you're going to have 5,280 feet per 1 mile and 60 minutes per 1 hour. And you go, well, multiply it, divide it, which one? If you figure it out this way, it'll basically take care of itself, right? Because numbers that are on top multiply, anything on the bottom is divided. Okay? Let's look at the next one. Car traveling 65 miles per hour per 1 hour, right? That's a rate. Then how far? Right? Does it travel in 2 hours? Right? So let's write this down. So 65 miles in 1 hour. Okay? So let's think about this for a minute. What do they ultimately want? How far? So which unit do we want to keep around? How far? Miles, right? And which unit do we want to go away? Okay, so hours is on the bottom, so we need something with hours where to get it, hours to cancel? Yeah, okay. So let's write it by, well, how many hours? 2 hours. And I'm just going to write it over 1 nothing, right? Just to make it look correct. Eventually you won't have to put stuff over 1, but I'm just trying to keep it all consistent, okay? So now, won't the hours cancel? Right? And now, without even thinking about it, I know that I have to multiply 65 and 2 because they're both on top, right? If one's on the bottom, then I know to divide, right? See what I mean? So when the things get more complicated, see how it'll just kind of take care of itself. I'm not asking you to set up every, egg and carton problem like this, but these are just simple examples to show you for when it gets complicated. So, all right. So what is 65 times 2? 130, and what units are left? Miles. Now, technically, 65 times 2, and then technically divided by 1, right? But that's not going to change it, okay? If there was some other 1, we'd have to divide down there, okay? All right, let's go to part C. We have a pizza. It's got 8 slices in it. We got 4 people, okay? So we have 8 slices of pizza getting divided among 4 people, don't we? Can we write that down? 8 slices for every 4 people. Okay? And what do they want to know? How many slices, right? Per people. Oh, wait a minute. They want to know slices per person. What units do we have there right now? Slices per person, don't we? Right? We already have that. So do we need to cancel out any of our units? No, right? So this is like in the final step over up here, because this is what they want. You get that? Nothing's got to cancel. They want a slice per person. That's what we got from our first setup. So now we know to do what? Divide the numbers, right? And what do we get? 2 slices. Yeah, I want to stay consistent and write for 1 person. That's our unit rate, right? Okay. I know it seems like I'm overcooking unit rate here, but again, when things get more complicated, it's helpful to think this way. All right, part D. Biker travels 20 miles in 1 hour. Okay? How many minutes does it take per mile travel? So they want minutes per mile. We're going to think about this one in a minute. Okay? They want how many minutes per mile. So eventually, we want to have minutes over miles, don't we? Because that's what they're looking for. And not the other way around, right? Not miles per minute. See how, get me? So we need to set this up right. So whatever we start with, right, what do we need to have on top? Huh? Time, minutes, and miles on the bottom, right? So 20 miles in 1 hour. Let's take that for a second. 20 miles for 1 hour. Let's get the part where now we get it in minutes. How many minutes are in 1 hour? Okay, so that's going to be 20 miles then in 60 minutes. So we're almost there. Okay, we now have minutes. Okay? We got miles in there. But remember, where's minutes down? It's down the bottom, right? They want it on the top. So could we just flip that? When we go back and work with it? Let's do that. So we want minutes on top. So let's write it like this. That's valid, right? Okay? Now, do we have the units they want? Do we need to cancel anything out? No. So now we just do what? Divide, right? And what do we get? 3 what? 3 minutes for every 1 mile it takes. Okay? So the couple we needed units to cancel, and a couple of them, like from our original setup, have the units they wanted. In this case, we had to flip it, right, because it's upside down from what they want. Does that make a little bit of sense to you? Okay. All right, let's move down here. Well, before we get to exercise, because they say more stuff here. Rates are all about multiplication, division, ratio. Yeah, ratio. Anyway, let me do this. I'm going to write, and I want you to write this down too. C note. So, I'll explain in a second. So down in this problem, we got distance and rate and time. When I write this down here, if you guys all flip over a couple pages, do you see a blank page that says the word notes on top? Okay. So when I write that, that's what it means. Because sometimes I like to add something they don't have here. So let's go to that notes page. Do you guys remember a formula for distance, rate, and time that you may have learned? Anything? If you have rate and time, how do you find the distance? Distance equals what? Anybody? Traveling at a certain speed for a certain amount of time. Let's say you're traveling at 50 miles an hour for 2 hours. How do you figure out? You multiply rate times time, right? Distance equals rate, your speed, times time. Or maybe you saw it this way. Does that look more familiar, maybe? Distance equals rate times time? Okay. So D equals RT. Distance equals rate times time. You know, maybe we could take this thing and get a formula for rate. Let me take this and rewrite it this way. R times T equals D. Is that valid? Rate equals signs. I can write it in either direction, can I? It's still valid? You'll agree? Okay. So let's say I want to solve this now and get an equation for just R. Get the R by itself. Something that looks a little more like an R, maybe. R times time. How do I get that R all by itself on that side of the equation? What's being done to the R right now as you're looking at it? Being multiplied by T. Well, we need to undo multiplying by T. How do you undo multiplying? Okay, so we divide it by T. But what you do to one side of the equation, what? Got to do to the other. So what? Right, T's will cancel on that side, right? You with me? So now we're just left with what? Equals D over the distance divided by time. That makes sense intuitively, right? Your rate, your speed, distance, miles, time, hours, miles per hour. Okay? Let's try it the other way. What if we wanted to solve this for T? I want a formula for time now. Because I travel? How long does it take me to get somewhere? What am I going to do? Yeah, divide both sides by R. I'm left with T equals D over R. Okay? Simple little equation. How many have seen this distance equation before? Last class, everybody saw it. Were you guys in a cave? I think even in a cave you get some math tutoring.
More like under a rock.
Even under a rock. You can get someone that you pay them enough, they'll tutor you under a rock. They're desperate. Okay, let's go. Everybody have this? Let's go. And by the way, if you ever get like behind copying the notes down when they do, don't sweat it, because this is all going to be on Teams later in the PDF, okay? All right, so don't panic. All right, let's go back here. So exercise 2, down the bottom of page 6. We got a runner traveling at constant rate, R, of 8 meters per second. How long does it take? That's time, right? To travel 100 meters. That's our D, capital D distance. 8 meters per second. What's the time it takes to get 100 meters? Well, they're going to start out by having us fill out a table here, okay? So he's running at 8 meters per second. So here's some numbers of seconds, and over here they want the distance. So for 1 second, how far has he traveled? All right, so really you did times 8, didn't you? You went 8 meters, okay? Down here again, they're all going to be times 8, right? Get over there, that's silly. Times 8 times 8. Okay, how far after 2 seconds? After 3. Or no, 5, sorry, yeah, you're 5 times 8 is 40. See, it's dancing. Hang on, screen's dancing. Okay. And after 10 seconds? 80 meters. Okay? All right. So that doesn't really tell us the answer to this yet, but it's helping us set up. I kind of already gave it to you, though, with the notes page there. So part B, create an equation. I think we got that already. D, the person has to run, knowing the amount of time. Okay? So we're just going to do this. D equals RT. But now let's use the numbers they have there. The only thing we know from the problem setup is 8, which is what part of that D, R, and T? Is 8 the D, the R, or the T? Okay, so here's his equation. Distance equals 8T. Simple enough, right? With me? So that's our equation for this specific case, okay? Now part C, so to solve a simple other equation based on B, the equation, that gives the exact amount of time, okay? So something that'll solve for time, right? Well, let's get this solved for time here, all right? So in this case, I want to write it the other way, because I have a hang up. I like my variables on the left hand side when I solve and get, because I hate when I get 3 equals x. It just feels weird. It's not wrong, and I'm not saying you guys have to do that, but I got a little hang up with, I got to have my variables on the left. It's like you put your shoes on the wrong feet and walk around. It doesn't walk, but it feels weird, right? All right. Anyway, so I'm going to write this like this. 8T equals how many meters? 100. That's our D, distance of 100. Okay. So what do I do to solve this for T? Okay, when you say divide it, be more specific. Just 100? Okay, so just this side of the equation? That's what I'm after, right? Both sides. Divided by 8. Divided by 8, and how much time does it take? Oh, nobody's calculating in their brain. I'll just tell you. How about 12.5 seconds? All right. questions so far? Okay. So we did some unit rates, unit conversion. We got some rates in an equation for distance. All right. Let's go to the next page. Look at our next example. That's our first paragraph. Previously showed blah, 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 blather, blather. The world of, yeah, fine, okay. Well, they talk a lot in here. Let's just go to exercise 3. Somebody want to read that out loud for me? Try to read it. Somebody else read it. You want to read it? Oh, you just made eye contact with me. You're reading. Exercise 3.
A man is walking across a 300-foot long field. At the same time, his daughter is walking towards him from the opposite end. The man is walking 9 feet per second, and the daughter is moving at 6 feet per second. How many seconds will it take for them to meet somewhere in the middle?
All right, let's think about this. So father and daughter, opposite ends of the field, walking towards each other. Are they walking at the same speed? No, father's going a little faster, right? 9 feet, what is it, feet per second? And she's only at 6. Got her little daughter legs, right? Little girl legs. You guys aren't very quick. Sorry, it's true. I'll bet you something a lot faster than you right now. Okay, so they're going to walk towards each other from both ends of the. How long is that field? Okay. And they want to know how long it'll take them until they run into each other? Okay. Will they end up running into each other exactly halfway across the field? Why not? They're traveling different speeds, right? So we'll be directly in the middle, okay? So when they do meet, though, when they do meet, what will be the total distance traveled by both of them together? When they do bump into each other in the middle of the field, somewhere in the middle of the field, how far will they both have traveled in total? There's one end of the field, there's the other end, they're coming. How far will they have traveled when they bump into each other? Back at the problem, see if there's something in there to help you. The two of them together will have covered a distance totaling how long? Oh, could be something I underlined. Possible. Let me ask it this way. How many know the number that I'm after but are afraid to say it? Raise your hand. Come on, man. How far is the dad and daughter going to travel all together? How long is the field? So how far are their distances going to add up to? 300, right? They're traveling across a 300-foot field and meet in the middle. They've covered the whole length of it together, right? You add them up, right? Right?
Yes.
Okay, all right. Well, let's start out doing it their way. Okay? So draw a diagram. Actually, this should say, does this look like a diagram to you? I don't know why they do this. Make a graph or a table. I'll keep track with man and daughter. R after 1, 2, 3, etc. Okay? So let's take a look at this here. So after 1 second, the father is traveling at 9 feet per second. How far has he gone? Okay? So really we're doing 1 times 9 equals 9, right? And how about the daughter? 1 times 6 equals 6 feet. What does that add up to? Oh, we'll do the adding later. So let's do the next one. 2 times 9. He's gone 18 feet. 2 times 6 is she's gone 12 feet. And then 5, right, times 9, 45 feet. 5 times 6, she's gone 30 feet. And then 10 times 9 feet for the dad. 90 feet in 10 seconds. She's gone 60 feet. Okay, let's get their total distances at each interval here, okay? So after 1 second, right, how far have they both gone in total? Right, 9 plus 6 equals 15 feet. After 2 seconds, have gotten 30 feet covered. And then 45 plus 30 is what? Yep. And after 10 seconds, 9, yep, 150. So, based on our table there, have they met in the field? Have they bumped into each other? Huh? No, why not? Well, they need to have covered together 300. They haven't done that yet, right? Okay. So it's going to take more than 10 seconds, yes? Any thoughts? Like how long it will take? Based on this? How long is the field? They got to get 300. Well, in 10 seconds, they cover 150. How long do you think it will take? Yeah. Another 10 seconds, they'll have their 300, right? So intuitively, that's what you're right, that's good. So, but the class is called algebra, not intuition, okay? So we're going to try and set this up algebraically. Let's answer part B. We kind of already answered part B. So what must be true about the distances the two have traveled when they meet? Their distances must add to what? They must add, we got that part already, to 300 feet. Okay? Now we're going to get the algebra. Create equations to predict the distance. Well, we have distance, rate, and time equation already, right? D equals RT, right? So we need one for the father, one for the daughter, because they're different speeds, yes? So let's do the father. Let's get an equation for the father. It would be D equals what? What's his rate? What's his R? So 19. Now I'm going to show you something. I'm going to introduce a subscript to you. You know what a subscript is? Because I'm going to have two D's, like two equations with a capital D, and I want to be able to just keep track of which one is which for the father and daughter. So, capital D, and I'm going to put a little subscript down, tiny f, right? That's a tiny little down below. It's called a subscript f. This is common in math, okay? Right? That means the distance of the what? Father, right? Use a subscript that makes sense, yeah? Equals, what is it, 9t, right? So D sub f, so you read that, the father, equals 9t. Now let's do the daughter. What would that be? Well, let's put a sub, how about D sub D for daughter, probably? Equals 6t, good. Okay? All right, so let's jump on the algebra bandwagon here. So we have these two equations for the distance that they travel. And what do we know about their two distances, their two D's? They must what? Okay, so taking that D and that D, give me a way to say that they have to, algebraically, that they have to add up to 300. Father's distance, which is what? D sub f, and the daughter's distance, must add to, how do we write that? Two things add to 300, right? So what? D sub f, go ahead, plus D sub D. There we go. Look at that algebra you guys are doing. That's algebra, okay? So this equation here has D for distance in it, right? The question, though, is what? That they want ultimately is what? How long? Time. We need T. Our equation doesn't have T in it. You wrote there. Wait a minute. You know if two things are equal, you can substitute them in for one another, replace them, can't you? Is that D sub f equal to anything with a T in it that we wrote before? Well, look for somewhere on the page with a D sub f and an equal sign. It's equal to, hey, that's got a T. So this D sub f, could I replace it with 9t? Because they're equal, right? So let's do that. So 9t plus, all right, what about our d sub d? What can I replace that with? Hey, now we got t's because they want time. 6t equals 300. You guys with me? See, substitute. Okay. I'm pretty sure you guys have done simple things like this. So what should we do now? We want to solve this for t. Right, well, what's our next step that we should do here? Right. Well, so first of all, are these what you call like terms? They're both t terms, so can I combine like terms here? Okay, so it's like 9 apples plus 6 apples. How many apples do I have? Okay, so I have 15 t's, right? So 15, I can combine them. T equals 300. Now, how do I solve it for t? Well, for t, almost. Both sides, thank you. Divide this by 15 and that by 15. That cancels. I'm left with a t equals 30 divided by 15. It is 20. Okay? You guys just kind of set up your own algebraic equation. 3 equations, really. Wrote one based on the first 2, then substituted in what was equal and solved. That's algebra, guys. Okay? All right, so we have to do a second lesson, but I just want to show you. If you flip the page and look at page 9, that's your problem set, right? So that's what you'll do tonight, and what you do when you come into class tomorrow, and we'll go over it. You'll tear it out and turn it in, okay? Again, we do have to do a second lesson. Sometimes we'll have to do a third, okay? But for the moment, we'll take maybe a 3-minute break here, okay?